Hi, everyone. I'm your host, Matt Salem, and you've tuned in to another episode of Our Best Behavior, brought to you by Behaviorally. We are the global digital first leader in providing data intelligence through our AI and tech enabled product stack to help brands own the most valuable moment in marketing, the purchase transaction. We are Behaviorally, the transaction experts. Each episode, we share insights on trending topics within our industry and of interest to our customers. Today, we're joined by Dr. Eric Siegel, founder of Machine Learning Week and Generative AI App Summit, a distinguished consultant and former professor at Columbia University renowned for his expertise in deploying machine learning solutions. Eric is at the forefront of exploring how artificial intelligence is transforming industries, reshaping organizations, and impacting individual lives. His best selling book, Predictive Analytics: The Power to Predict Who Will Click, Buy, Lie, or Die, has become a staple in hundreds of university courses, showcasing his profound insights into the field. His newest book, The AI Playbook: Mastering the Rare Art of ML Deployment, is another one that is a must read and that we'll hear about today. With a knack for bridging the gap between technology and business, Eric's interdisciplinary approach has earned him accolades, including the Distinguished Faculty Award during his tenure at Columbia University, where he taught graduate level computer science courses in machine learning and artificial intelligence. Eric, thank you so much for joining us today. Really appreciate it. Glad to have you here.
Thanks, Matt. It's great to be on the show.
So, before we dive into the discussion for today, I'd really love to hear a bit on the intro there. Certainly lots of accolades, a lot of cool stuff. Love the title of Predictive Analytics: The Power to Predict Who Will Click, Buy, Lie, or Die. But of course, there's the newest AI playbook as well. So, if you can introduce yourself and perhaps just drop a little background, I'm sure our listeners would appreciate that.
I'm trying to be a business person stuck in a nerd's body. I've been in the field of machine learning for more than 30 years, and I got into it for probably the same reason most data scientists did, which is that it's the coolest, most awesome, fascinating, and potent kind of science and technology, which is that it learns from data to predict. It ascertains patterns and generalizations from a limited number of examples, even though it may be many examples, that turn out to hold over the many unforeseen future situations, scenarios, examples, and cases. The fact that it holds out, that it's learned something true, that's amazing stuff, right? So that's sort of how I got into it. And as they say, I'm a recovering academic. So my interest is in actually capturing, not just generating potential value, but capturing value with this technology. And that's the theme of my new book that you mentioned, the AI Playbook, which is that what happens is the science is sound, the analytics, the number crunching. The data scientists used existing machine learning methods usually within pre-existing software that implements those methods to learn from the data. But then what's learned, the predictive model, doesn't get deployed. And this is a routine problem with projects. So my interest as an independent consultant as of 20 years ago has been in realizing that business value. But what's continued to become more and more apparent over those last 2 decades is that we're still not realizing that value. We're not capturing it because the power is stuck in PowerPoint. We create these great models, we talk about them, but actually acting on them turns out to happen less often than not. And so that's sort of my verve these days. That's my mission. I want to see these models actually get deployed.
And not using PowerPoint as much, perhaps?
We just got to get out of the PowerPoint. We're stuck there. Yeah.
So you obviously have the bestseller already in hand. The AI playbook is newer. I want to dive into that a bit and maybe even start with the full title of the AI playbook, because we talk about AI, but obviously in that title we talk about mastering the rare art of machine learning deployment. We're talking about machine learning, and many times when I'm talking with clients I hear the two terms used somewhat interchangeably, but my understanding is there's obvious differences. So maybe you can dive in there to get us started.
Well, there may or may not be differences. It depends on how you want to use the word AI. Here's there's good news and bad news. The good news is that you can use the word AI however you want because there's no agreed definition. It's completely subjective. If we're trying to ascribe the concept of intelligence, which is nothing if not a human specific concept, to a machine, there's a problem with definitions, and there's also a problem with managing expectations. That is to say, hype, where the expectations are mismanaged. We're kind of expecting the machine to come alive in the ultimate rendition of that idea because it's intelligent. It's we anthropomorphize it one way or another. That's a problem. So oftentimes when people say AI, they simply mean machine learning. And more generally, if machine learning is the next best thing since sliced bread, and I've already tried to make that case today, um, most of the world knows of it as AI. And my books are meant for business readers, not just data scientists. Both of them, neither one's a require reading for the other, and they both do provide an accessible introduction to the field. The first book, Predictive Analytics, is how machine learning works and delivers value. The second is how to capitalize on it, and how, what it takes organizationally and in terms of leadership and project um, playbook. That's the titular playbook, how to actually run the project so that it successfully deploys. So we want to reach the broad audience who knows of machine learning more as AI than anything else. AI does, of course, also mean more than that, as depending on the speaker and the context. Although typically what it's describing is either a particular way of using machine learning, as for example generative AI, where you're using machine learning to generate new content items like writing and graphics, um, and images, or it sort of is implying that there's something else besides machine learning that's advanced technology, uh, where there usually isn't. So it does tend to be vaporware, going back to the whole hype thing. It's a very subjective term, but machine learning is very well defined. It's learning from data to predict, and that's the holy grail for driving all large scale operations of organizations in marketing and targeting, fraud detection, credit risk management, et cetera.
Well, something we touched upon in my last podcast with our guest, and I'd love to get your perspective as well, is just this idea of where do companies even start? I mean, you'd be remiss not to have a conversation today that involves AI in some way, shape, or form with clients. We're constantly having those conversations here at Behaviorally. I think part of that is because it's just inherent to the products that we offer. But regardless of that bigger picture, AI is a main component of conversations these days in the business world, hence your books. How do companies learn where to start? There's so many different areas of business that AI can be incorporated into. It could be incorporated to help ease operational load. It could be incorporated to creating better products. So, talk to me about some of those potential sticking points, and really more so, how do they ascertain where to start?
You start with value. You start with the way operations are going to improve, the way you're going to actually make business better, right? Change that in a good direction, something concrete. That's the antidote to hype. That's the antidote to today's overblown narrative about computers becoming as capable as humans in general. Um, I didn't, I realized I didn't quite finish my thought. I said there's bad news and good news. I said the good news is you can use AI however you want because it's a subjective term. That's, of course, also the bad news, because people are using it in ways that imply more capabilities or more near term capabilities than are feasible. Um, so starting with value, well, oftentimes the best returns are look at your largest scale operation in targeting, marketing, fraud detection, credit scoring, these things I mentioned. Which satellite to investigate is running out of a battery? Which train wheel might fail? Where's the best place to drill for oil? Any and all of the large scale operations that are a numbers game. Business is a numbers game, and if you tip the odds a bit in your favor with prediction, with probabilities on the outcomes for each of these individual cases, and drive decisions on the basis of those probabilities, those predictions, that's where you tip the numbers game slightly in your favor, which ends up having a dramatic return on the bottom line. Prediction is one of the last remaining differentiators in order to improve large scale enterprise operations. And prediction only comes from machine learning by definition. Machine learning is the way to leverage data, because it's the best leading methods to ascertain patterns and formulas or any kind of insights from that historical data. Data is history. It's a recording of previous experience. It's things that happens in the past, and so you derive from it a predictive model, which then applies on a per case basis to drive millions of decisions as far as where to drill for oil, which satellite to investigate for running out of battery, who to contact, investigate, incarcerate, set up on a date, or medicate. And all of these operations are being done driven with predictive models. Everything I just said is essentially what can be known as predictive AI in order to differentiate it from generative AI, also known as predictive analytics, the title of my first book. Or you could just call it enterprise machine learning.
Mm.
Whatever you want
Mm.
to call it, oftentimes those are the best use cases, and it depends on your organization. Where is there a large scale operation? Operations consists of many decisions, often yes no decisions. um, and how do you improve those decisions with prediction? So that's the exercise. What you simply need to get a handle on is what's predicted for this use case and what's done about it. There's a third thing, which is how well is it predicted. What are the pertinent metrics in terms of purely it's pure predictive performance and the potential improvement to bottom line business metrics that you'll get by deploying it. And when I say deploy, what I'm talking about is actually changing existing operations, integrating those predictions, those probabilities to actually improve and thereby change these large scale operations that consist of many decisions. um, of course, there's also when you hear the term AI, um, oftentimes over the last year and a half, they're talking about generative AI. And that's really a very different ball game. The two are kind of apples and oranges, even if they're built on the same underlying technology. Um, but generative is great for writing first drafts or creating first draft images or images and videos. Also, first draft of code. But I emphasize first draft because you very much, unlike many of these predictive applications, with generative, you almost always need a human in the loop. You can't trust it. It can be very time effective and improve efficiencies because it does create the first draft. But you do need that human looking and seeing whether it met the mark and making sure there aren't any red flags with the content that it created. Um, so the generative in generative AI is not a reference to any. I mean, there is a specific category of technical approaches, but the word generative isn't a reference to those. It's a reference to the use case, the way machine learning is being applied, namely to generate a new content items, or that is to say, first drafts of content items. And then generative also, of course, helps sort of with brainstorming. You're kind of like, what if I wanted to, market to a, you know, improve the outreach of my pharmaceutical company to a new segment, or just decide what kind of other pharma to consider acquiring as an enterprise. And you kind of want to ruminate, and you want to have your partner in crime and have some back and forth. That's potentially valuable. You hear a lot of anecdotal wisdom that in some cases those types of interactions with generative, with a chatbot like ChatGPT, can be fruitful. um, but it depends on how you phrase the question and what you've already thought of, and whether it's
Mm.
novel, and the degree to which you're sort of leaning on it. So it can be really hard to put a number on the value of using it, but it is ad hoc. Can't hurt to try. um, those uses are very casual because by definition it's operating with natural language. So it's meant that anybody can just start in and start typing with it, right? And just to have an
Mm.
interaction. There's no particular expertise required. Just go ahead and try it. Whereas for large scale enterprise operation improvement, which is the predictive applications, that's an enterprise level thing that requires us only arithmetic to understand from the business standpoint, but some very particular arithmetic, because we're talking about uh, improving large scale operation. That's where the focus of most of my work is. Of course, generative's only a year and a half old, and I've been in the field for like 32 years. Um, and of my books, and one of the two conferences, Machine Learning Week. The other conference, Generative AI Application Summit. Those two conferences, by the way, come the first week of June in Phoenix.
Good place to be, Phoenix in June. Maybe finding a pool nearby, hopefully at some point during that visit. But hey, as you were bringing
Yeah.
up Chat GPT, which is obviously something that comes up in a lot of the podcasts that I'm taking part in, and a lot of the conversations generally. One thing that we know about it is that it can make mistakes, right? I mean, it says it right at the bottom of the page, basically, when you're on there. We've seen it make mistakes. And when I think about predictive AI and going back to some of your points earlier, using it at an enterprise level, finding the value and unlocking the value, what are the chances of predictive AI leading you in the wrong direction? I mean, I had watched some of your videos that you had posted online, as to what some of our listeners may know you as, Dr. Data. And when I was watching some of those videos, I saw this whole concept of overlearning and finding patterns that aren't really meaningful. And, I'm curious about the juxtaposition of generative AI versus predictive AI with regard to the potential to or not to make mistakes. And does that really come from having too much data? Because on the one hand, it's kind of a two-part question, I guess. You hear about the more data, the better, generally amongst data scientists. But then to me, it seems, which, I'm not certain in asking you, that if there's overlearning happening and patterns being identified that aren't really supposed to be helping, really, is that coming from having too much data? Is that only going to happen in those cases? So, two-parter there, if that makes sense.
Yeah, to address your question sort of in reverse, no, there's not really any such thing as too much data. If the data is sound, if it's good, and if it's representative of the way in which you plan to act on what you've learned, the way in which the situations into which you expect to deploy the model moving forward. So if it's representative, it's sound, definitely the more data, the better, the less likely of what they call overlearning or overfitting. Um, so, can predictive send you in the wrong direction? Well, if nothing else, predictive is an exercise in evaluating how well it predicts in an objective way. So, although there are technical things that can go wrong, the whole process is discovering those before deployment. And the way in which that's done is that you have held aside test data. So, it's, you know, the idea of learning from historical cases, who in the past clicked, bought, lied, or died, so that you can predict in the future who will click, buy, lie, or die, right? You leveraging. When people talked to when we were calling it big data for a while there, the excitement was because we were collecting lots of data as a natural byproduct of conducting transactions, and that now we could leverage that by learning from it. In that sense, we aren't in most of these predictive projects, we aren't doing extra data collection. We're simply leveraging the data that already exists. It's also known as found data. So, um, but when you want to leverage that data and learn from it in a way that you can expect to be reliable and robust, that it will continue to predict as well, and not like a magic crystal ball. It turns out that you only need to predict better than guessing, and it's not feasible or realistic to expect to predict who was going to click, buy, lie, or die, commit an act of fraud, or turn out to be a bad debtor. We don't have clairvoyance, so we can't expect computers to either, but predicting better than guessing turns out to generally have a dramatic effect on the bottom line. Predicting 3 times better than guessing could improve the ROI of a marketing campaign by a factor of 5 or more easily. That's just back in the napkin arithmetic that I've gotten a bunch of my videos and both of my books. Um, uh, so we want to make sure, though, that it continues to predict about as well as you expect it to. And you might think, well, gee, that's going to take a whole bunch of really sophisticated math and theory to sort of figure out what are the principles of learning. And the technical word is induction. Deduction is using what you've learned. A implies B and B implies C. So if you know A, you can get to C. That's deduction. But that's applying what's learned. The learning that is making finding the means in the madness, that's induction, where you've got a lot of examples, and that's the learning data that's literally called training data. That's one thing to sort of figure out how to learn from the data. The other is sort of how do you know the soundness of what's learned? It turns out that you don't have to use really sophisticated, highfalutin math and theory, which only goes so far and makes a lot of assumptions that don't hold in most cases anyway. Instead, it's this mind-numbingly simple, very elegant, universal way that's not just best practices. It's literally the only practice that any data scientist would ever use, basic for all intents and purposes, which is you hold aside unseen test set. So you take your learning cases and you take, let's say, 20% a random sample, you quarantine it, you don't let it use those examples when it's actually doing the number crunching, so it can't cheat. And then once it's done and you want to check out the predictive model, see how well it performs, you try it only on that test data that was held aside. That serves as an objective basis for measuring how well it performs in general over unseen cases. So you always have that fail stop, even offline before deployment, of getting a sense that you're, not falling into any of these terrible pitfalls, including overlearning, where it's basically might have fit the data too well, in the sense that what it learned doesn't apply in general, but it was particular to that list of examples that you gave it. So you
Mm.
want to avoid that. It's generally quite avoidable, but you make sure by having that separate test set.
So you mentioned better than a guess. A guess to me is, you could be right, you could be wrong, a 50-50 type thing, right? So
Yeah.
give give our listeners an idea. What's better? Is it literally if you could just gain a percentage point or two? What's that back of napkin arithmetic that would generalize how much you can have an impact?
So one of the main metrics of performance of a model is something simply called lift, which is like basically a predictive multiplier. So if you're doing targeting marketing, and let's say you've got 1% response rate, which is actually relatively high for targeting direct mail, for example. But let's say it was a 1% response rate. If the model identified a pocket of customers that had a 3% response rate, well, look, you still don't have high confidence of any individual they're going to definitely buy. But you know that within this pool, there's going to be 3 times as many of average, 3% rather than 1% of them are going to buy. So that's called a lift of three. So in that sense, you're predicting 3 times better than guessing. Of course, that kind of thing, that kind of metric, that there's a lot of different metrics all the data scientists use. They use that and gains and precision recall, area under the curve. There's a whole bunch of them. These technical metrics tell you only the pure predictive performance. They tell you basically how much better than guessing or how much better than some other baseline for comparison. They only tell you the relative predictive performance. Of course, what you also really want to know is the business value when you deploy it. What's going to be the returns, the profit, the dollars saved, the numbers of customers saved, the business metrics, the KPIs that matter. How will its deployment beyond these technical measures of predictive performance? How much value will it actually capture when you actually act on it by deploying the model, by deploying its outputted predictive probabilities? Um, Going to business metrics is something that's rarely done, but is an absolute necessity. And I've actually co-founded a company called Gooder AI to do exactly that.
Hmm. Want to tell us a bit more about Gooder AI?
Yeah, so we this is the last main remaining technical solution in the ecosystem of machine learning software that's needed to actually succeed in getting to deployment with more regularity. Right now, the track record's quite bad. Um, most most models that are created by data scientists with the intention of being deployed actually don't get to deployment. I spent a year as a visiting analytics professor at UVA Darden School of Business about a year ago for a year. And part of that was helping with some industry research across data scientists. Other research shows the same results. IBM pretty recently released industry survey results showing that most enterprise machine learning projects, or they call it AI projects, uh, fail to achieve returns, in the sense that the average returns are actually lower than the cost of capital. And we believe that's largely because they simply don't get deployed. These failures are very readily swept under the rug, especially these days with all the AI hype that kind of helps with that sweeping under the rug, and people are adept at that. But it's not sustainable. We need a more uniform organizational practice. I call that practice BizML, and that's the purpose of my book, The AI Playbook. And a core central component of that, when it comes to technical solutions, is the ability to take a model and say, "Hey, look, I understand this thing predicts better than guessing. I understand it has a lift of three, or an area under the receiver operating characteristic curve of 0.89. But I want to put these into business terms. What's the profit or returns? What's the improved profit of a targeted campaign, or making credit decisions, or targeting fraud detection with this model?" Well, when you're going to deployment and you're trying to make a decision, this is exactly ultimately what matters, especially to your client. If you're a data scientist, to the stakeholder, to the person in charge of running the operations meant to be improved by the model. Well, how do you do that? You can't just say, "Hey, look, this predictive model is worth $1 million." It depends on how it's intended to be used. So that's the magic, and that's the thing that we're offering with our product at Gooder AI. Instead of just measuring the absolute performance of the model, you want to measure its business value, in terms of KPIs and metrics like profit, but you can only do that relative to how it's going to be used, how it'll be deployed. So our solution is a general platform across use cases where you can interact with it, try what if scenarios, and say, hey, look, if I deploy it this way and I use it to target the top 5% most likely customers or most likely transactions to be fraudulent, and I make these assumptions, and you're visualizing it, you're trying it out, you're stress testing it in that way, and you're finding out the results, lo and behold, in terms of profit rather than just these relatively arcane technical metrics of performance.
Very cool. Very cool. I love the idea of BizML and really just changing what are otherwise, mathematical terms into ROIs for business. That sounds like what a lot of folks out there want, crave, and need. So
Yeah.
definitely check out Gooder, check out the AI Playbook. I know in that book you talk about processes for deploying machine learning. I'm sure some of what we've discussed in the last few minutes is in there as well. As we begin to close, wanted to ask you a bit about something I saw online, the fact that I think you're a part-time rapper. I saw the end of Dr. Data. The song. I want to know what the influences were there. I want to know.
Yeah.
I used to be a hip hop DJ back in my heyday in college, so it struck a chord with me in a positive way, in a positive vibe, and I thought it was cool. And I was like, all right, this is going to be a really cool interview. Eric seems like a cool dude, so
Well,
I got to hear about that.
thanks for watching. Predict This is my extremely mildly famous uh, pedagogical predictive analytics rap music video at predictthis.org, just 3.5 minutes long. Please don't get distracted by the campy video about what it does to your social life to be a nerd, and listen to the lyrics if you somehow can, because they tell you everything you ever wanted to know about predictive analytics and we're afraid to ask. I can't say that I'm a part-time rapper because that implies I would ever get paid for it. I would definitely say I'm a very tongue-in-cheek, uh, avocational rapper. And I am a rapper, though. There's no question about that, in the sense that I utter prose rhythmically that rhymes. So that makes me definitely a rapper. You cannot
Definitely.
definitionally, and you can't question that.
No question. Maybe the pro bono rapper. Is that a
Okay.
fair
Pro bono, yes, out of the kindness of my heart, I've given it all to you for free.
Well, I really appreciate it, Eric. That was fun. Once again, thanks to our listeners for tuning in to Our Best Behavior here, brought to you by Behaviorally. Appreciate all the listeners tuning into every episode. I'd like to thank Eric one more time for coming on today, for his insights. Be sure to check out his books. Be sure to check them out online. And be sure to check out the next episode of Our Best Behavior here. With that, we'll catch you next time.
Thanks, Matt.